No.
All right. Hello.
Hi, everybody. Welcome back.
Welcome.
We are ready to talk about a little bit of factoring.
Factoring. Love factoring.
Now, we know you've loved factoring now since Algebra 1.
And Algebra 2.
And maybe some of you FST. But we have some other strategies to show you that you may or may not have seen.
So a quick review of something done and maybe an example or two of something they haven't.
Absolutely. The
Perfect.
key here is factoring is essential. If you cannot factor, you're not going to make it much past higher math
Now,
classes.
it's something you need to be able to do it, and we would like to be the last day we talk about it is, today.
Pretty much, yeah. All right, the first step in factoring is
Take out a greatest common factor.
take out a greatest common factor. Is there one thing in everything that can come out? Okay, so we have 5x to the fourth minus 7x to the third plus 3x squared. So look at the numbers, 5, 7, and 3.
Nothing in
there.
common. That's what the C for
Nothing in
common
common.
factor.
X to the fourth, x to the third, and x squared.
Well, they all have at least an x squared in them.
They all at least have an x squared. So let's go ahead and take that x squared out.
So taking out a common factor means what?
Kind of means dividing, actually.
Okay.
Okay? If we have x to the fourth, remember that means there are 4 x's. So I'm going to put 2 of the x's in front of the parentheses, and we're going to have the other 2 x's left over afterwards. Remember, this is backwards of distributive property.
So we're undistributing.
Undistributing it is.
Is that a word?
It is now.
All right.
All right, so in the middle term, we've got 3 x's, or x to the third. We're going to put 2 of them in the front, 1 left over with the 7 here. And on the last term, we've got a plus 3x squared, so...
Parentheses.
Thank you.
And we're done.
We were talking about the 3 and the fact that the x squared is already in the front.
All right, so this should be like old hat.
Easy, easy. Okay,
All right, next one. Same idea. We start off the same way. I'm going to do this one.
you want me to write?
Sure, you could write. We're looking for a greatest common factor. We see that 18, 57, and 45, they're all divisible by what?
3?
3.
Okay.
But the first term's negative, and just because the first term's negative, we're going to go ahead and get in the habit of taking out a negative value when there's a common factor. So we're going to go ahead and take out a negative 3 as our common factor.
Okay.
All right, so we'd have negative 3, then in parentheses.
Can we take any x's out of this one?
Nope, no x's out because the last term of 45 has no x's in it.
Okay.
So we don't have any common x's.
Alrighty.
All right, so what's left when we divide out a negative 3? We have 6x squared. Notice that's a positive 6x squared now. Then we're going to have a negative, and 57 divided by 3 would be 19x, and negative 45 divided by negative 3 would be positive 15. Okay, now, we're not always going to be done at this point. We want to look now at the remaining trinomial term, if you will.
Okay.
And we're going to try to factor 6x squared minus 19x plus 15. And there are a lot of ways to factor. In fact, if you ask 5 different people from 5 different places, you might find 5 different answers.
Maybe 6.
Yeah, exactly. So here we've decided to use a box method for factoring. It is not something that you are required to do it that way. If you already know how to factor a certain way that works, by all means, just get the factors correct.
Absolutely.
We're going to use the box. We're going to run through it one time as a quick reference. There's a PowerPoint slide on the Algebra 1 section of the tutorials that if you need some help going through this, please go click on that. Okay?
Absolutely. Another time the box is really handy is when this first number is not a 1.
Sure.
If it is a 1, it's kind of mundane to do a box.
Sure.
But this one's a 6, so that gets a little big. Okay,
So
what
how's
should
this
I do?
box thing work?
Okay, I guess I'll draw a box, Mr. Lucky.
So we draw a box. We put 4 little spaces in there, and the first term is always going to be the x squared term.
Okay,
So in the last term is going to be in the bottom right corner.
okay,
And then we're going to multiply the a and the c terms together. So the 6 and the 15 make 90.
yep.
And so that's a times c, and then b is negative 19. And what we're going to have to look for is 2 numbers that multiply to make ac and add to make b, which means 2 numbers that multiply to make 90 that add to make negative 19. How about negative 10 and negative 9? This process might take you a few more seconds, and it's just trial and error. There's no magic wand to go hoo-hoo, poof.
And if you're not so good at guessing and checking like that, just start writing stuff down.
Yeah, start with 1. Go 1 times 90, 2 times 45, 3 times 30, 4 times whatever 4 goes into 90 in. But just start making a list until you find 2 numbers that multiply to make 90 that add to make 19.
Okay.
All right, but then we wanted negative 19, so they both had to be negative.
All right?
So we're going to put both of these. Now that 90 really was like a 90x squared, and the negative 19 was a negative 19x.
Yes.
So both the 10 and the 9 both needed x in there.
Okay.
So we're going to have negative 10x and negative 9x. It doesn't matter which box we put them in?
Not at all. It can go in either order, okay? As
All
long
right.
as you keep the sign in the box with it.
Absolutely. Okay, so now we got to figure out what goes on the outside of the box. And the way we're going to do this is instead of staring at it and randomly trying to figure it out, we're going to find the greatest common factor again
Yep.
of the first row.
Of the first row. So
So-
what goes into 6 and 10?
2.
What goes into x squared and x?
How about an x?
Perfect.
So now we can complete our box. We got to multiply 2x by the top, and that'd be 3x to make 6x squared. And 2x times the other side would be negative 5. And then we're going to go 3x times something makes negative 9x, and that would be negative 3. So our factors are going to be the outsides of the box, 3x minus 5 and 2x minus 3. Again, if this does not seem very familiar at all, please go check out the PowerPoint. It explains it in better detail and more thoroughly.
And
now,
come see us.
what are we missing from our final answer here that
Well,
we had to begin with?
These two parentheses really only represent this one parenthesis, so we are actually missing this term.
So it still needs to be there.
It still needs to be there.
You see that phrase that says factor each expression completely? That means take out the greatest common factor and finish off any factoring that can be done as far as you can go and write down
Yep.
all of your answers.
And whenever you see something that looks like something squared, something with an x, and then, I'm sorry, an x squared, an x, and a constant, you definitely want to be thinking that trinomial, the box.
Think box
Okay.
or factoring. Okay? Perfect.
And you want to check them in that order. Check your GCF first. All right, so difference of two perfect squares. Here's another one. This is a case where the box can definitely work. However, because we
Way
use
too
this
much
so often, if you can memorize this little pattern,
You just
Okay.
need to look at it and just say, ooh, I know what it is.
yes, and the way you recognize it is it's called the difference of two perfect squares. So you need to recognize perfect squares, things that when you square root, you get a whole number, okay?
And
you want to
difference
know
means what?
subtract. Thank you.
Subtract.
So when we look at letter A here, we want to factor each expression again. We've got 9x squared. 9's a perfect square. X squared is a perfect square. Okay.
So what did we square to get 9x squared?
So we had to take something by it times itself to get 9x squared. We took 3x times 3x. So this could be rewritten like this. Okay. There's our minus in the middle. It's a difference. That's good. What did we square to get 25y squared?
How about 5y?
How about 5y? Okay. Now, if you recognize this, this is like your A, and this is your B. So I don't remember necessarily A plus B, A minus B. I remember first thing plus second thing, first thing minus second thing. It's up to you how you want to remember it. Okay. So now we're ready to go ahead and follow this pattern right
So
here.
no box necessarily, we just get to
No
write
box,
the answer?
we need to go straight to the answer.
Awesome.
3x plus 5y, 3x minus 5y.
And that's it.
And that's it, you're done. If you can recognize that pattern, it's way simpler, and it'll really serve you well.
So the next one works out just like that, right? It's going to be 6x plus 7 and 6x minus 7.
Well, you would think so, except for this is called the difference of
Oh,
squares.
man.
The pattern only works if you have exactly perfect square minus perfect
So
square.
can we do anything with the plus
We
sign?
can't do anything with this at all, so this is not factorable
Oh, well that made it easy.
if we recognize it. Otherwise, we beat our
So
head
it has
against
to
the
be
wall.
a squared minus b squared.
Also, remember when you're factoring to double check your answers, what do?
Multiply it all out.
Multiply it all out.
Foil
Foil
it
it
out.
together. Use a box to multiply. You should always check your work. There's no reason to miss a factoring question.
None.
Okay? All right, so now we need to take this up to the pre-calc level. We've been
Yes.
doing Algebra 1, Algebra 2 level. So let's get to pre-calc. What's a little different about this one, Mr.
Well,
Dickey?
this doesn't look like a normal factoring problem
Not so much.
far. Okay, you want me to do this one?
It's all
All right,
yours.
so when we're looking at this,
It looks like a big mass.
it looks like a really big mess. But what do you notice that is very similar in some of this problem?
Well, I noticed a 2a minus 3 in a couple of spots.
So we've got this 2a minus 3 here, and we have it here. And in the first part, it's squared, and in the
Okay.
second part, it's not squared. So
And the third part is not there at all.
correct. So what we're going to do, just to make this a little easier for ourselves, we're going to do a little substitution here.
Okay?
All right, we can pick our favorite letter. What's your favorite letter?
Well, A is my favorite.
Of course, but it's already used, so you can't use it.
Let's pick C for Coca.
All right, C. All right, we're going to let C equal 2a minus 3.
Okay?
That is what we're going to plug into our problem now.
Okay, so it would be 3c squared?
So we're going to have 3c squared plus 17c plus 10.
Okay.
Now that looks exactly like our other
Hey,
problem.
that looks like the box that I just did.
It's exactly like the box. So
Okay.
hit pause, try to factor it yourself, and go from there. Okay, welcome back. And now we're going to try this. Shall we do it together, or should we just give them the answer?
No, just go for it.
Just give them the answers. This is going to be 3c, and this is a c, and then we're going to get, what do we got here, 5 and 2
Yep.
with plus signs everywhere. Okay, and so that's what it's going to come out to be. Again, if you need help with the box, please get to class and ask the first thing you walk in. We'll be happy to explain it in more detail.
Okay, but Mr. Lucky, is that our final answer? Because that has a C in it, but the original question had this 2a minus 3
You're right.
thing
We're
in
not
it.
done, are we?
We're not quite done yet.
Okay, so we have to put everything back into our problem the way it was before.
Okay.
We had let c equal 2a minus 3. So what we're going
Right.
to do is everywhere there was a c, we're going to replace it with 2a minus 3. So we're going to
Okay.
have 3 times
2a
2a minus 3 plus 2,
Okay,
and then 2a minus 3
okay.
plus 5.
Oh, well, that's not so
And then technically that is finished, but let's go ahead and clean this up just for
Should we
fun.
pretty it up?
Let's pretty it up.
So distribute your 3.
So we're going to distribute the 3 in the first bracket,
So
and we're
about
going to get
6a minus 9 plus a 2.
And in the second bracket,
There isn't anything to distribute. 2a minus 3 plus 5.
2a minus 3 plus 5. So let's go ahead and clean this up.
6a minus 7
This will be 6a minus 7
and 2a plus 2.
plus 2. What do you notice now, even though we're almost done here?
What am I supposed to? Oh, there's a 2 in common.
They got a greatest common factor of 2 in that
Ooh.
second factor, so
We
we
should
actually
probably
should
take that
take it
out.
out if we're going to keep going this far. So we're going to pull the 2 out of here, and we're going to leave it out front, and we're going to leave this as a plus 1,
Okay.
and there's nothing else for this one, so this is 6a minus 7. And there is our final, completely factored form.
So whether or
Of this
not
problem.
we see a greatest common factor at the beginning or we see it towards the end when we've already started working the problem, we should always take it out.
Always.
Okay?
In fact, if you miss it at the first time, and you catch it after you're done, it just means you worked harder than you needed to. But if you
Probably.
pull it out when you're, even after you're finished with the little, each factor piece, it'll still be correct.
Great. All right, one more strategy I think we need to show you, and that is,
Her job.
what if we have 4 pieces to begin with? Well, if we have 4 pieces, here, you can have that. If we have 4 pieces to begin with, we can do what we call a double GCF, okay? So sometimes this is also called grouping. So in other words, let's just look at it half at a time. I'm going to chop this in half, and I'm going to be very careful not to chop through the plus because then it looks like a minus. And we're going to chop between the first 2 terms and the last 2 terms and just kind of look at it as 2 separate questions, okay? If you saw 4a to the 4th plus 24, 4x to the 4th plus 24x to the 3rd. Mr. Lucky, what do you think we would do?
Well, they have a greatest common factor of 4x cubed.
They do, so let's take it out. What would we be left over with?
We'd be left with x plus 6.
Okay. All right, so we looked at our first half. Now let's look at our second half over here. What about 5x plus 30?
Well, we've got a 5 in common.
Okay, and did you want to use a positive 5 or a negative 5?
Let's pull out a positive 5 because
Okay.
it's a positive 5x.
Absolutely. So remember we talked about if that first term had a negative, then we'd be taking negatives out. But this
Absolutely.
one doesn't, so we're going to use a positive. And left over we would have,
X plus 6.
oh, wait a minute. Once again,
This kind of looks like the last problem a little bit.
never find the highlighter. There's x plus 6 and x plus 6, okay? Kind of looks like the last one a little bit. So again, if you had something that looked like this, 4x cubed, Mr. Lucky, what's your favorite letter?
L.
L for Lucky, okay. Plus 5L, would you recognize that you could take an L out of that
Yes.
and have 4x cubed plus 5?
Yes.
Okay, but our L happens to be
X
this
plus 6.
x plus 6 group. So we're going to take the x plus 6 group out and have 4x cubed plus 5 left over. Okay,
And that's it?
and that's it. So this is called grouping. How do you recognize grouping? It works really well with 4 pieces. And by the way, if you really wanted to and you're a box person, the cool part about the box and the reason you do an ACB table in the first place is because that gives you 4 pieces. Well, didn't we already have
already
4
had 4
pieces to
pieces.
begin with?
So could we
couldn't-
just put them all in the box?
Absolutely. And some people choose to grouping with a box. It's just a style thing if you're more visual. And if you're really good at the box in the first place, then a lot of times you like to keep going with the box. So again, what's
Greatest
in common?
factor of the first row would again be 4x cubed.
Oh, yeah, let's use 4.
6 doesn't go into 4. Shh. All right.
4x cubed. Okay, and we would have x plus 6. There's the 6 I was
All
thinking.
right. And
then
that would be a
plus
5.
And you
And-
see we're going to end up with the same, whoop, that one's over there.
X plus 6 and 4x
2
cubed plus 5.
factors.
So
Okay.
whichever way you like better, does it matter?
It doesn't matter. Doesn't matter.
Well, that's
So-
it for factoring then.
That's it for factoring.